Optimizing Retrieval-Augmented Generation. I want to share my experience on developing RAG applications for organizations. So let's assume that you have implemented or that you're about to implement a RAG solution for your organization. So the next thing is that people start coming to you and they compliment you on how well the application performs. On the other hand, every now and then they come to you and they report issues or problems in the application. So this video is about identifying the specific issues that the application is having and doing targeted fixes for those issues, or systematic RAG improvement process. This is also the process of taking a proof of concept RAG application to production level. In this video, I will next tell you why I want to do this video, after which I will introduce myself, and after that we will do a short recap of RAG internals, and after that we will have a look at the data that you need to collect in order to be able to identify issues in RAG applications, and after that we will go through the process of identifying issues in RAG applications with some pointers to how to start fixing them. I want to do this video because most of the materials out there are labeled to be advanced materials on RAG development, but before any of the advanced methods can produce consistent improvements, you need to fix the basic issues first. The second reason why I want to do this is because a lot of materials out there are tool-centric, such as setting up RAG in 5 minutes with LangChain or Llama Index, but setting up the application is just a starting point in RAG development process. And thirdly, a lot of the videos out there are materials from companies that have productized RAG solutions, and now they're trying to sell these solutions to you. So in order to evaluate and understand how those solutions work, you need to understand the basics first. And the fourth reason for me doing this video is that I see a lot of model centricity in the field right now, because new great models are being published every week, and this hype about the new models kind of like creeps into RAG development projects, and then you have this issue that people come to you and they suggest changing the model every now and then, and before identifying what is wrong with the application, they come to you and say, change the model, there is this new great model available that we should use in our RAG application. Even if you would use the latest and greatest model available, that model would be operating on top of the unidentified and unfixed issues in the applications, and using that great new model wouldn't produce optimal results. My name is Henri Kynsilehto. I'm a machine learning engineer, a data scientist and a data engineer. I have been developing natural language processing applications for 15 years now. And of course, like everybody else in the industry, I have worked with the generative AI for the last couple of years, and including some RAG applications. So I would like to share my experience. This is my first YouTube video, so I'm very excited and a little bit nervous. So let's see how this goes. Let's do a quick recap of RAG applications or RAG internals. The RAG internals are the performance factors of RAG applications, so we need to understand how they work in order to understand their contribution to application performance. So here I have a picture or a diagram of a RAG application internals, and if we zoom to the top left part of this picture, we will find that something called chunking happens here. So your organization might have PDF documents, even PDF books that needs to be used in a RAG application. And one thing that we need to ensure for these is that the material that we create from source material is short enough that it will fit into the LLM's context window. So LLM is one part of the application, and they have a limited context window into which anything that they process must fit. So long documents need to be split into shorter documents so that the LLM can process them efficiently. Messaging platforms can also be used in a RAG application. So take for example Slack and Slack messages, but a singular Slack message does not contain context for understanding what the message is about or what it is related to. So you might, for example, have a Slack thread in which begins with a question by some participant, and then some other people get in and they answer the question. So actually what needs to be done for individual Slack messages is that the individual Slack messages from a thread are combined into a singular document, and this document then has enough context for the LLM to understand what the individual messages in the thread are about, and this Slack thread will then become a document that can be used in the RAG application. Company wikis can be used in a RAG application, so they, for example, Atlassian Confluence or files from Google Docs, and often these wikis contain material that has not been so well edited. So using material from wikis brings issues of its own, and these issues has to be accounted for. Interesting development is using source code from version control, and this is interesting development because we finally see some additional value added on top of source code and source code comments. However, when source code is used, the application might spill out implementation details, so this is something that you need to understand and account for if you use source code in your RAG application. So, chunking begins with source materials, which are split into short enough documents, and sometimes transformations are done for these materials, and the end result is documents which are short enough and possibly with some transformations. Okay, so we have some documents. The next thing done in a RAG application is indexing, which is creating an index out of the documents, a searchable index of the documents. Nowadays, indexing is usually done by vectorizing. In vectorizing, we create a vector presentation of each document or embeddings for each document, and these embeddings are then stored in a vector database, which can then be used for searching documents. And the vector database will then serve as the index for your RAG application. Other methods can also be used for indexing, for example TF-IDF, which is an older search and retrieval algorithm. Even direct text search can be used. For example, you might have short content as source materials, and in this case vectorizing doesn't usually work well, so you might decide to use some other method instead of vectorizing. In general, the chosen indexing method must match the content, must be suitable for indexing the materials that you have, and to be usable as a search and retrieval method for your source materials. So indexing starts with the documents that were created during chunking. The documents are then indexed according to the chosen indexing algorithm and stored into the index, which will later be used by your application for search and retrieval on basis of user queries. By the way, notice this line running from bottom left to the top right. So this line actually divides the build time of the application from runtime of the application. So everything left of this line is build time. Chunking and indexing happen during the build time of the application, and everything right of this line is runtime. So everything that we talk next happens during the time when the application is running. So during the application runtime, each transaction begins with the user entering and querying the application. The user's query is then used for search and retrieval from the index, and the application gets some matching documents from the index, and these documents are called the context because they are the context for the LLM for generating the response to the user's query. So search and retrieval phase begins with the user entering, and the user queries the application, and then the query is used for finding documents with the index, and then in a good case the application finds some matching documents for the query, And this is the end result of search and retrieval, the matching documents or the context for the LLM. So next phase in a RAG application is prompting, and in prompting we have the matching documents that were found during the previous phase, and we also have the user query available. Additionally, we have something called prompt template. The prompt template contains instructions for the LLM for generating the response, and also some placeholders which will during prompting be replaced with the found documents, the matching documents, and possibly also with the query. What is important here is that the prompt template must instruct the LLM to generate a document of the required type. In a simple Q&A application, the prompt template might instruct the LLM to just answer the user's query on basis of the found documents. In a more complex case, the prompt template could, for example, instruct the LLM to generate a document, a new document on basis of the found documents, a document that makes sense considering the purpose of the RAG application. But in any case, prompting begins with the matching documents and the user's query and the prompt template. And during prompting, the placeholders in the prompt template are replaced with the matching documents and possibly with the user's query. And the end result of prompting is the prompt, which is just an instruction for the LLM to generate a response of the required type, supplemented with the found documents and possibly with the query. The final phase is generation, which is actually quite simple. The prompt that was generated in a previous phase is simply given to the LLM, and the LLM generates the response. So we begin with the prompt, and that is given to the LLM, and the LLM generates the output. So let's do a quick summary. During chunking, the long documents are split into shorter documents, and possibly some other transformations are done for the documents. And during indexing, from the documents created during chunking, we create an index, a searchable index of the documents. And during search and retrieval, the user's query are used in searching documents from the index. And during prompting, the found documents and possibly the user query are used with the prompt template to generate a prompt for the LLM. And during generation, the prompt is simply given to the LLM, and the LLM generates the response. In addition to understanding the RAG internals as the performance factors of RAG, we need to collect some data in order to be able to debug problems in the application. So, in order to be able to identify issues in RAG application, you need to have the chunking and indexing logs, because things can go wrong during chunking and indexing. You also need a reference to the source materials. Now remember that the user is now complaining about the RAG performance, and user's expectation that the RAG would perform well is based on their existing some source material that the application can use while it is generating the response. You also need the user input that the user used, and of course the user will tell you this, but you also need to store this in the application logs so that you can search the logs with the user's input. You also need to have the found documents, the documents that were found for the query, and you can only get them from the application logs, so be sure to log them. You also need to store the prompt in order to be able to analyze prompting and to know if something goes wrong in prompting, and you also need to store the generated response, maybe just for the clarity. So this is the information that you need in order to be able to identify the specific problem and do a targeted fix for that issue. The runtime logs for each user query should be kept in a singular log message so that you can conveniently investigate runtime issues. You might consider having a process for collecting feedback on the RAG application performance. Especially if you're with a big organization, there could be a lot of feedback coming in, and it would be good to have some structure in that process. We're now at the last phase of this video. We are ready to go through the steps of identifying issues in RAG application when there is some feedback on the poor performance of RAG application. I will also try to provide some pointers towards fixing those issues. The first thing to look at is the user input and the generated output. Do they really mismatch? Sometimes users have quite high expectations on RAG performance, and the first thing that you should do is to evaluate the issue in each case. So if you don't agree with the user on the poor performance of RAG, you need to chat with him and try to sort things out with him. But in any case, evaluating and assessing the issue is the starting point for fixing any issue in any application. Suppose that you agree with the user that there is a genuine problem in the RAG application. The next thing to look at is the reference to the right source material. Remember that the user's expectation on the good application performance is only based on their existing some source material that the application can use when it is generating the response. And also, you as the developer of the RAG application, you might not be aware of all the materials that the organization has. So it is fair to actually ask for the reference to the right source material, because the user is expecting the application to use some specific materials when it is generating the responses. And if you don't have the reference to the source material, ask for it. So if you got the reference, the next thing to check is that you can find the source material. Is it available? If your reference to the source material was a link, then it is fairly straightforward to follow that and verify this. But if your reference was some other description, then you're gonna have to go and look for the source material. And if you can't find it, then you're gonna have to ask user to help you in finding that source material. And if it turns out that the source material doesn't in fact exist, then there is not much more that you can do for this particular problem case. So if you were able to find the source material, the next thing to check is that was there document or documents created during the chunking for that particular source material. For example, permission settings sometimes can prevent the application from reading the source materials, and sometimes it can happen that the application cannot interpret some source material, and in this case there won't be documents created during the chunking for the source materials, and you're gonna have to find out what is wrong in chunking and fix that. So document or documents were created during chunking. The next thing to check is that are these documents okay? Maybe the documents are still too long, so it's fairly straightforward to understand this if they're too long to fit to the LLM's context window. It's also quite easy to see if the documents are broken. For example, in your Slack case where you want your Slack threads to be combined into a singular documents, but knowing if the documents are too short is a bit more difficult. So if the documents are too short, then there is not enough context for understanding what is being said in the documents, and this is a qualitative feature of the documents, and it can be a little bit difficult to know this for sure. So if the documents are not okay, again, you're gonna have to check what is wrong in chunking and fix that issue. If the documents created during chunking are okay and they should be fine, then the next thing to check is that they're indexed, they are in the index, and you can actually verify this by using the document text and searching the index for the documents. For example, if you use vectorizing and you at some point you decided to change your embeddings model, then you would have documents with embeddings from different vectorizing model in your index, and then during the runtime you would be using a different embeddings model to vectorize the queries. and then you would not be able to find the documents from the index. With TF-IDF, sometimes the vocabulary can be somehow unfortunately distributed so that the algorithm doesn't work well for those documents. And sometimes the indexing just takes very long time and you're trying to find the documents in the index while the content is still being indexed by the application. But in any case, if the documents cannot be found in the index, you need to check indexing and fix that, or at least understand what is going on with the indexing. If the document is in the index and it can be found via the index, then the next thing to check is that was it actually found for the particular query. Remember that the user's expectation on good application performance is based on the application using the particular material that the user intended to be used for his query. If the document was not found for the query, the next step is to ask why it wasn't found for the query. And one thing that you might find out is that no documents at all were found for the query. And in this case, you probably have a very difficult mismatch between your indexing method, between your search and retrieval and your document base. For example, you might have short content and you're using vectorizing, and your vectorizing just isn't efficient indexing and search and retrieval method for short content. On the other hand, you might find that some other documents were found for the query, and in this case there are several options. For example, you might find that you are actually indexing archive materials, and in this case you could fix this by limiting the indexing somehow. On the other hand, you might find out that you're using company wiki and there are some not so well edited materials found for the query, and the application uses these for generating the response. And in this case, the best approach might be that you go and talk to the people who are responsible for that content in the company wiki. So it is maybe better that you as the application developer don't try to fix this by yourself, but propagate this issue to the other people in the organization. So if the right documents were found for the query, our list of possible errors in the application is actually getting quite short. So the next thing to look at is the prompt. Have a look at the prompt in the logs. Does that look good? And the way to evaluate this is actually quite simple and intuitive, because the LLMs, they read and generate responses in a similar fashion to the human beings. So you could do something like jump into the LLM shoes, have a look at the prompt and think if you could actually generate a good response to the prompt. For example, it might turn out that the prompt does not instruct the LLM properly to generate a document, a response that makes sense considering the purpose of the application. And in that case, you could fix the issue by changing the prompt template so that LLM is properly instructed to generate a document of right type. Other types of problems can also happen during prompting. For example, it might turn out that the documents are not properly injected into the prompt template, and it kind of like never stops to amaze me that how the data can always break the expectations of the application developers. So the content can actually break out of the prompt template in a similar fashion that happens in an SQL injection attack, where the attacker creates text that breaks the query and then nasty things happen in the application. So to fix this kind of issue, you can check that the documents are escaped and quoted properly. And if you implemented the application yourself, of course this can happen, but I wouldn't be surprised if this kind of issue could also happen but in RAG solutions developed by the big companies. So analyze the problem in prompting and try to figure out how to fix that. So if the prompt looks good and the right documents were found for the query, there is one last thing that we need to look at, and that is the LLM used by the application. So the LLM often needs some capabilities in abstraction, generalization, and reasoning. In a simple RAG application in a Q&A app, the LLM will just fetch a piece of information and pass it to the user. But in more complex cases, the LLM will actually need to apply something that it reads from the found documents to new cases. And in this case, the LLM might fall short of this. It might not have the sufficient capabilities for abstraction, generalization, and reasoning, and in applying what it has read to new cases. Another possibility is that the LLM is actually hallucinating. Originally, Retrieval-Augmented Generation was invented in order to prevent or limit hallucination by grounding generation to the documents. But of course, this does not make RAG immune to hallucinating, and sometimes hallucinations do happen. And but in any case, if you have either of these problems, you could try another LLM model. I would like to repeat that, in my opinion, changing the model should be the last fix to do for a RAG application, because if you just change the model without fixing the other faults, hidden faults in the application, then the new great LLM cannot reach optimal results. The other problem in changing the model is that the changes in prompt and in the model will reflect to all output generated by the application. So you would need some way of making sure that the generation does not get worse in general when you're fixing some singular problem in the application. So you probably need a fixed test set of test generation cases and some automated way of evaluating that the generation results are good after you change the model. So for these reasons, I think that the LLM shouldn't be changed every now and then, and that it should be actually the last thing to change in an application. So let's wrap this up a bit. I hope that you now have a better understanding of RAG and RAG internals and how they contribute to RAG performance. I also hope that you now know what data you need to collect in order to be able to debug and fix RAG applications, and what to look for, what to look at first when there are some problems, and have some pointers to how to start fixing these issues. Additionally, I hope that you have gained some understanding of the user expectations in RAG development process and can do some expectation management. I hope that this has been useful for you. Thank you for listening, and good luck to you for your RAG projects.